All right, learners, in this question, we're going to look at energy, potential energy, kinetic energy, mechanical energy. That is what we're going to look at in question 8. A man carries a briefcase of mass 5 kg while he climbs a ladder from the ground to point P, which is 3.1 meter above the ground. When he reaches point P, the man drops the briefcase. Ignore the effects of air resistance. Now, 8.1, the question is define gravitational potential energy. What is that, class? Is the energy an object possesses because of its position in the gravitational field relative to some reference point. What is gravitational potential energy? Is the energy an object possesses because of its position in the gravitational field relative to some reference point. Right? That is the answer for 8.1. Okay, now let me go to 8.2 and do it with you. Calculate how much potential energy the briefcase gained when it reaches point P. So we have the formula to calculate the potential energy, EP is equal to mgh. Okay, so I think what are we going what is it that we're going to do? Let me write it this side. Wait, so that I can create enough space for the next questions. Let me say 8.2. We write it this side. So EP is equal to mgh. What is the mass? It's given up there. You can see it's 5. What is G? It's 9.8. What is the height? You all see that is 3.1. Okay, so you press your calculator. What are we going to have? It's 151.9 joules. That is the gravitational potential energy. That is the answer for 8.2. Okay, so 8.3, what is the question saying? State the law of conservation of mechanical energy in words. What does it say? State that in an isolated system, the total mechanical energy of a system remain constant. Don't forget. It states that in an isolated system, the total mechanical energy of a system remain constant. Don't forget, learners, about that. You can repeat the video. It states that in an isolated system, the total mechanical energy of a system remain constant. That is the answer for 8.3. Now let's go to our last question for this part. 8.4. Determine the kinetic energy of a briefcase when it hits the floor. Justify your answer by means of calculations. Okay, so now what are we going to do? Since we have the kinetic energy, so we're simply going to remember it's conserved. So we're going to write the formula EK plus, we're going to write the formula. What does the formula says? EK plus EP top, right at the top, is equal to EK plus EP at the bottom. That's what I'm going to do. Okay, at the top, what is it that we're going to have? We're going to have our EK there. At the top, it's 0. Our EK at the top is 0. Our EP, we got it, it's 151.9. And then we're looking for this EK at the bottom. And then EP at the bottom is what? It's 0. I don't know if you get that. It's 0. So these zeros will cancel. So the answer will be EK will also be 151.9 joule. Do you know why EP at the bottom is 0? It's because EP is equal to mgh. So if ever your h is 0, everything become 0. At the bottom, the height is 0. On top, the velocity is 0. That's why at the top part, EK is 0. You see? All right, learners, that's all from me. All the best in your examination or test. All right.